uh, process that you are carrying. Okay, and absolute internal energy you cannot calculate, but you can calculate the change in internal energy. Also, it is an extensive property and a state function. And then we have started this first law of thermodynamics, which is related to your internal energy. Am I audible clearly, right?
Yes, sir.
Okay, thank you. So also remember that this first law of thermodynamics that I'm going to write float, first law of thermodynamics, is based on conservation of energy, conservation of energy. And this is that the delta U, that is your change in internal energy, will be equal to the heat exchange. Either it will be given to the system and given by the system, or work done. It is the sum of Q plus W, which says work done on the system or work done by the system. Did I tell you the sign convention for this? Sign convention of this internal different, like, wait a minute, let me just check it. No, no, okay. Sign convention is very important. This is your sign convention. So as you can see, sign convention. If work done, if you are going to do work on the system, work done on the system, that means you are doing work on the system, then the work done will be positive. But if work done is by the system, that means work is done by the system, then the work done will be negative. It's very important. The sign convention is very important. You will see I'm going to do some, we will do some questions in which the sign positive or negative is very, very important. Also, heat given to the system, heat given to the system, if you are going to give heat energy to the system, that will be positive. But heat given by the system, if system is giving heat out of the system, then it will be negative. Everyone getting my point? Yes or no?
Yes, sir.
So these are very important point. Now we are going to apply this formula. Just wait a minute. Please do write that. This is your question, and I'm gonna give you a relation conversion. 1 liter ATM is almost equals to 101.3 or 101 joule. So please do this question, which is very important. I gave this relation or conversion unit because in this question, you need to calculate the delta U in joule. So please do it. Just go take my water. Let me know when you are done, please. And if you are not able to do anything, just let me know, please. Any answer, Mamuna, Saif, Farhad, Iba, Alan, and Hanifa? That's the wrong answer, Saif. I told you to be careful about the unique sign, right? Maybe you're right. Let me just check it. Oh, very good, Alan. Finally, you replied. Yesterday, you were not responding at all. Everything good? Very good, Hanifa. Okay, I'm going to explain. See, a gas is allowed to expand in a well-insulated container. You know what is well-insulated container? That means heat can neither go out and nor come from outside. That ensures that the wall is adiabatic. If you remember, adiabatic, insulated wall or boundary, that means the wall is adiabatic. And if you remember, in adiabatic process we learned that q is equal to 0 in case of this adiabatic process. Now moving to the next part, against a constant external pressure, that ensures you that it is irreversible process, right? It is irreversible process of 2.5 atm. External pressure is your 2.5 atm. From initial volume 2.5 liter to final volume 4.5 liter, the change in internal energy of delta U of the gas. So initial volume is, you can see, delta U according to Flood, that is first law of thermodynamics. Delta U is equal to Q plus W. And as I told you, the wall or the boundary is insulated, so the Q will be 0 and W will be written as minus P external into delta V. So this delta U is directly equal to minus P external into delta V. Now you can see this delta U will be equal to minus P external. That means minus is in the formula and here it is 2.5, and delta V final volume, that is 4.5, minus initial volume, that is 2.5. Now you can see minus 2.5 into 4.5 minus 2.5, that will be equal to 2, and that represents your 5 liter ATM. This is not your answer because in option you can see that the answer is given in joule. So what you need to do, convert this into joule. So how you are going to convert it? You are going to multiply it by 101 and you will be getting minus 505 joule instead of plus 0 plus 5.0 plus 505. So the answer is B, not C. Seth.
Yes, sir.
So where you have mistaken, just
I just took pressure as positive.
okay, okay, very good. I'm gonna give you two questions together of 2010 and 2008, and I think you can do this easily. How? Are you able to see the screen, everyone? Oh, it's not working again. Just wait a minute, please. Please do this. Each of the following are not a state function. Okay, let's see. First of all, the first question. 3 moles of an ideal gas expanded spontaneously into vacuum. You know what will happen in vacuum? In vacuum, P external is equal to 0. And if P external equals to 0, you know the formula is minus P external into dV. So if P external is 0, work done will also be 0. So the answer is A. For question number 10, not a state function. If it is a state function, that means it depends upon initial and final. Or if it is not a state function, that means it is path function. And path function, as I told you, that depends upon initial and final as well as on the path. That means basically, I gave you the example of this, that is Q and W. So Q and W is your path function. Q and W is your path function. What about Q plus W? In the previous class, as I told you, Q plus W is basically delta U, which is first law of thermodynamics. And this is your state function. This is your state function. So the first option that you can see, Q and W is not a state function. This one Q plus W is function. But what is this new quantity? If you remember, this you have studied in your class, G will be equal to H minus Ts. We will study about this. This is formula of Gibbs free energy, and you know that this delta G is your Gibbs free energy. And I told you Gibbs free energy is also a state function. So which of the following are not a state function? So that is Q and W, and answer will be 2 and 3. So the option is correct option is D. Can I change this slide? Everyone, are you done with this?
Yes, sir.
Okay, moving to the last topic of this internal energy. If you are going to calculate internal energy, and if the process is carried out at constant volume, if the process is carried out at constant volume, can anyone tell me if the volume is constant? If the volume is constant, what will be the value of work done? If the volume is constant, what will be the value of work done? So you know work done, since V is constant, that represents delta V or dV will be equal to 0. Delta V or dV equals to 0, and hence work done will be 0. Is that clear? If your volume is constant, then change in volume is 0. And if the change in volume is 0, that represent work done will be 0. Yes or no? Is this clear to all of you? Mamuna,
Yes, sir.
Farhad, Saif, Alan. Now, according to Flot, that is first law of thermodynamics, you know that delta U is equal to Q plus W. So this will be represented as delta U is equal to Q. Why? Because at constant volume, this work done will be 0. And we are going to write this as this. See, QV. In subscript, you can see V, that represents heat exchange at constant volume. So whenever heat exchange, basically, I'm going to write a sentence, heat exchange at constant volume will be equal to change in internal energy. So in the question, it might be given the heat energy at constant volume is 100 joule or anything that indirectly represents the internal energy. So the examiner will play with its examiners will play with their sentences. Not they will not directly give you the heat, internal energy. Maybe they will give you heat exchange at constant volume is this that indirectly represents your internal energy. And I just proved to you that this delta U will be equal to Q heat exchange. Heat exchange, why I'm using, because heat can be given to the system or heat can be given by the system. That's why I'm directly using exchange that will represent both given to or given by. Are you getting my point? Please
Yes, sir.
Yes,
do
sir.
write it. Thank you. Let me know when to change the slide. Just 1 minute, please. Everyone done with this? Saif, Mamuna, Farhad.
Yes, sir.
Okay.
Yes, sir.
Let me say. Everyone knows what is endothermic, right? And everyone knows what is exothermic. Can anyone tell me that in endothermic process, delta U will be positive or negative, and in exothermic process, delta U will be negative or positive. Delta U, internal energy. And if it is endothermic, that means energy it will take. If it will take energy from surrounding, its internal energy will increase, and hence the final internal energy increases minus initial. So for endothermic, delta U greater than 0, and exothermic, energy it will release to the surrounding, and hence the delta U will be less than 0. I think it's clear to you, right? Everyone done with this?
Yes, sir.
Okay. The next quantity that I'm going to introduce is your enthalpy. So we already know about this. Enthalpy is your state function, first of all. Then it is also extensive property, if you remember, extensive property. Now, what is this enthalpy? So basically, I'm just going to write the mathematical equation of this enthalpy, which says enthalpy will be equal to internal energy plus PV. PV is your work done. You can take it like that. This is also a type of energy. Now see what will happen here. As you know, we cannot calculate the exact or absolute value of internal energy in the same way. We cannot calculate the absolute value of enthalpy. So we calculate change in enthalpy as we did in case of internal energy. So here it will be delta U, sorry, at the place of delta H, we can write delta H will be equal to delta U plus P delta V, P delta V. P delta V. So this is your new formula formula. So please do write it. And with this, no, there is another important point. Heat exchange at constant pressure. That means basically QP. This represents basically your, this P represents constant pressure, will be equal to change in enthalpy. QP will be equal to change in enthalpy. Please do write it. We can also write this formula delta H in terms of for especially for chemical reaction. Please do write it. Are you done with this?
Yes, sir.
Okay. Now for chemical reaction. For chemical reaction, you can see delta H will be equal to delta U plus delta NGRT. And you know delta U is internal energy, delta H is change in enthalpy, R is gas constant, T is temperature. What is this delta Ng? So delta Ng is equal to number of moles of gaseous product minus number of moles of gaseous reactant, as we did in case of, if you remember, as we did in case of, just wait a minute, chemical equilibrium chapter. Kp is equal to Kcrt raised to the power delta Ng. That represents we are going to take only the moles of gas, not liquid, aqueous, or solid. Okay. So there are some questions on this topic, which is quite easy and important as well. So we are going to do that. Okay. Yeah, here it is. So everyone, how are you feeling? Because your admit card is released today, right?
Yes.
Anyone's downloaded it?
Yes.
Okay, very good. What about you, Saf? There is another question that is very important to you. And that is your best question, which also comes from 99. The next question. That comes from here. So there is three questions that I have given. There are three questions. Any answer from any one of you? Sir, it's wrong answer for question number 38. No answer from anyone. Okay. See how much easy it is. For the reaction this, you need to calculate delta H. And you can see RT is there. So apply the formula. Delta H is equal to Delta U is internal energy and delta E both. So I'm gonna write delta E because in the question it is given. I'm gonna use this delta NGRT. Either you are going to write U or E, it is the same. Now, in the question, it is delta E that is given, so we don't need to calculate. Delta is E as it is. Now, delta NG you need to calculate. Can anyone tell me what is the value of delta NG for this reaction? Delta NG is basically number of moles of product. Product side you are going, and NH3 is in gaseous state because it's Haber process. So number of moles of product 2 minus number of moles of reactant. You can see this is hydrogen which is in gaseous state, nitrogen also gaseous state. So 3 plus 1 total number of moles of gaseous reactant, so it will be 4, so that will give you minus 2. Putting the value of delta Ng here, delta H will be equal to delta E minus 2 RT, and hence the answer will be your B. Isn't it easy? Mamuna, sir.
So what is delta E?
Delta E, as I told you, if you remember in the when I started this, just wait a minute. When I started internal energy, I think I told you that this E or U both are same. Internal energy we represent either by E or either by U.
Okay,
Is
sir.
that clear? Now see, for a cyclic process, which of the following is true? Is not true. Basically, I told you in a cyclic process, the value of a state function, the change in value of a state function will be equal to 0. So you know a state function is delta H, delta U or delta E, internal energy, delta G, delta S, P, V, T. These all are state function. And if you are going to calculate the change in this state function in a cyclic process, it will be 0. So delta H will be 0 in case of cyclic process. True, true, true. But work done is path function, which is not true. So our answer is not ABC, but our answer we need to calculate it the not true. So answer is D. Is that clear, everyone?
Yes, sir.
Now I think you can do the question number 33. Please do it. I'm waiting. Let me know any answer if you get any answer. Are you done with this? Very good, Saif. Mamuna, Hanifa, Farhad, Alan, Hiba. Okay, I'm gonna calculate this. So as you can see, we need to calculate delta H minus delta E. So this is the formula that I told you. Now what we need to calculate, the value of delta H minus delta E, that will be equal to delta NGRT. Only we need to do is the calculate the value of delta Ng, which is equal to number of moles of gaseous product minus number of moles of gaseous reactant. So come to the reactant part. This is in gas, this is in liquid. So you are going to ignore it. Only the number of moles of product which is in gas is 3. So I'm going to put 3 here minus number of moles of reactant. You can see both are in gas. One of the mole is 1 and one of the mole is 6. So you are going to just add it. And then you can do 3 minus 6. That will be minus 3. And hence, if you are going to put the value here, delta H minus delta E will be equal to minus 3 RT. So simple. So the answer here will be C. Everyone done with this? Please do write it and let me know. Everyone done with this? Alan, Farhad, Hanifa, Hiba, Saf. Can I change the slide? The next topic is entropy. And we represent it by S. Entropy is basically, entropy means disorderness or randomness. Disorderness or randomness. So basically, I can define the thermodynamic quantity. Please do write with me. Which measure the randomness present in the system is called entropy. So it's very easy. Mathematical equation of this will be delta S system will be equal to Q reversible upon T. This is the formula that we will apply to get delta S system. Please do write it and let me know. So when we need to measure the randomness of the system, we are going to introduce a term that is your entropy. And here entropy is basically degree of randomness or disorderness. And from here we got a formula delta S system is equal to Q reversible upon temperature T. Now the most important part, on which factor does this disorderness depend? So I'm going to write factors on which entropy depend. Entropy, or we can write disorderness or randomness depends. So basically, the first factor is your physical state. Now I'm going to ask you a very simple question, which says that Can you tell me the entropy of gas, entropy of liquid, and entropy of solid? What do you think? Randomness in the system. If you have three system of you have three container, of which the first container is in gaseous state, basically not the container, the particle is in gaseous state in the first container, and in the second container it is in liquid state, and in the third container it is in solid state. In which container randomness or disorderness will be maximum? What do you think? Saif, Farhat, Mamuna, please do answer whatever is coming in your mind. Alan, Hiba, and Hanifa. So you know that in gaseous state, the particles can move freely. So there will be more and more randomness. So in gaseous state, there will be maximum disorderness and hence maximum entropy, then liquid, and then comes your solid. The next we can go for is temperature. If you are going to increase the temperature, if you are going to increase the temperature, what will happen? The particle will gain energy, heat energy, and it will start moving faster than the earlier, and hence the randomness increases and also the entropy increases. The next we can go is for pressure. You know what will happen? If you are going to increase the pressure, the volume will decrease. And if the volume will decrease, if the volume is very less, they cannot move more easily as compared to the previous one. And hence the entropy decreases when you are going to increase the pressure, and vice versa. If you are going to decrease pressure, volume will increase and they can move more freely than the earlier, and hence the entropy will increase. Everyone getting my point? Yes or no? Last but
Yes.
not the least, very good. For chemical reaction, you know, this delta Ng will be equal to number of moles of gaseous product minus number of moles of gaseous reactant. If delta Ng greater than 0, that represents in product side there is now there is more number of moles in gaseous state, so S will increase and hence delta S will be positive. What I want to say is very simple. If you have this PCl5 in gaseous state, and if you are going to convert this into PCl3 gaseous state plus Cl2 gaseous state. Now on the product side, if you will see, if you are going to calculate delta Ng, that will be equal to 1 because in product side there is two number of moles of gas and there is only one number of moles of gas. Now disorderness will be maximum on the product side because there is more number of moles, and hence if you are going to calculate delta S, it will be positive because final entropy increases and initial entropy and initial entropy is lower because there is only one mole, and in the product side you have two mole, so delta S will be positive. Are you getting my point? In the same way, if delta Ng is lesser than 0, that means number of moles of gaseous product decreases and hence delta S will be negative or delta S is decreases. So it's very simple and very important. Please do right. Let me know when you are done with this. Are you done with this?
Yes, sir.
Thank you, ma'am. I'm going to give you a question. Write the sign of delta S in the following. Question number one is to write it. N2 in gaseous state. You need to write the sign whether it is positive or negative. NH3 in gaseous state. Calcium carbonate in solid state. Two moles of hydrogen gaseous state. N2 gaseous state at 5 bar. N2 still gaseous state at 3 bar. Crystalline solid. And again in crystalline solid. At 0 Kelvin, at 115 Kelvin. Any answer for the first one, A, whether delta S is negative or positive? Very good, sir. Okay, everyone, here you can see whether the delta S is negative or positive. So you can see number of moles decreases, entropy decreases, and hence it will be negative. You can see initially it is in solid and finally solid plus gas. Due to this CO2 gas, there will be more randomness. Final entropy increases, so it will be positive. Here you can see it is 2 mole and it is 1 mole. So 2 mole will have more entropy, more disorderness than 1 mole, so it will be negative. Here you can see 1 mole N2 gas, 1 mole. Both are 1 mole, and gaseous state. But here pressure is more, that means volume is less and entropy is less. But here the pressure is decreases and hence volume increases and hence the disorderness increases. Now, both are in solid state, crystalline solid, but here it is 0 Kelvin and here 115 Kelvin. Temperature increases, entropy or disorderness also increases. So the answer is this. Is that clear, everyone?
Yes.
Sir, can you explain again? The
Okay,
last
I'm
two
going to
one
change
only.
this. The last one. Crystalline solid, both are solid. Okay, let's say both are solid. This is at 0 Kelvin and this is at 115 Kelvin. So if this is, you can see temperature increases. When temperature increases, particles will get energy and they will there will be more randomness as compared to the previous one. That's why delta S will be positive. Here the randomness increases due to increase in temperature. Is that clear?
Yes, sir.
Yes.
Okay. Now see, the next topic is entropy change in a chemical reaction at constant temperature. This is the condition at constant temperature. Now, there is a formula. If you want to calculate the change in entropy for the reaction, it will be equal to the sum of change in entropy or the sum of all the value of delta S of product minus sum of all the value of delta S of a reactant. Now you can see if you have this reaction H2 in gaseous state plus I2 in gaseous state, that is giving you 2HI in gaseous state. 2HI in gaseous state. So here the value of the change in entropy of the reaction will be equal to, you can see, first you are going to check the delta S of HI. Delta S of HI, this is your product, and only one product is there, so you just need to write this, and whatever is the number of moles, there is two number of moles, so you are going to multiply it by 2 minus, you can see there is two reactant. So what you are going to do, delta SH2 plus delta SI2, and you can see there is only one mole, so whether you are going to multiply it by 1 or not, it will not affect, and accordingly you are going to put the value here, here, and solve it. You will be getting the value of change in entropy of the reaction. Please do write it and then let me know. Everyone done with this? Everyone done with this?
Yes, sir.
Okay. I'm going to give you a question. H2 in gaseous state. The question is similar to the previous example that I have given. Exactly same. And here it is given that entropy of H2 is equal to 133 joule per Kelvin. Entropy of Cl2 is equal to 236 joule per Kelvin. Entropy of HCl is equal to 186 joule per Kelvin. Calculate delta S reaction. Uh, again, Saif, your answer is correct. Wait a minute. Yeah, it is correct, not wrong. Unfortunately, I wrote wrong. Any answer from any one of you? See, it's very easy. If you want to write the delta S reaction, it will be equal to, I'm going to write delta S sum of delta S product minus sum of delta S reactant. So you can see for the product, it is given HCl and there is 2 moles. So 2 into directly 186. And then you are going to minus. You can see H2 and Cl2. H2 has a value 133 plus this has a value which is 236. So what I'm going to do, 2 into 186 I'm going to do. So it will be 372 minus, if I'm going to add 133 plus 236, this will be equal to 369. And if you are going to, so it will be 3 joule per Kelvin. Isn't it easy? All of you. Can I change the slide?
Yes, sir.
Okay. Now see, we have this change in entropy during phase transition. That means liquid to solid, solid to liquid. Phase transition. Please do write it. First of all, it is entropy of vaporization. Entropy of vaporization. So if you are going to write the entropy of vaporization, that means liquid into gas. So delta S system will be equal to, as I told you, Q reversible upon T. So here, since we are specifically talking about vaporization, so Q will be represented by delta H vaporization upon T. In the same way, for the second, we can go for entropy of fusion. Entropy of fusion. And hence, entropy of fusion is solid into liquid. And delta S fusion can be written as delta H fusion upon T. Directly I wrote it. The next one is entropy of sublimation. We can go for entropy of sublimation. You know, sublimation is solid into gas directly. So delta S sublimation will be equal to delta H sublimation divided by T. So these are some common word that we use, which is very, very easy. Everyone done with this? Start taking a general organic chemistry. Everyone done with this? Saif?
Yes, sir.
The next topic is Gibbs function, or you can take it Gibbs free energy. Gibbs free energy. Now, what is this? As you know, again, this is your extensive property, state function, and also if it is a state function and we cannot determine the value of g, so we calculate the value of delta g. Now, its mathematical equation is g is equal to h minus ts. Now, as you know that we cannot calculate the absolute value of g, so we calculate the value of change in Gibbs free energy, which will be equal to delta H minus T delta S. So this is the new formula for Gibbs free energy. And this Gibbs free energy is very important because if Gibbs free energy is zero, that means the process is at equilibrium, And if this delta G is less than zero, that means the process is spontaneous, that will not require any external force or pressure or temperature. And if delta G greater than zero, then it is non-spontaneous. So please do write it. I'm going to give some questions to you. In 2020, there is a question from me. This is the question that I just gave you. Any answer? Saif, Hanifa, Farhat, Alan, Hiba. See, it's very easy. We need to tell the examiner that what will be the sign of delta S and delta H. So first we are going for delta S. I'll look into it, Seth. Delta S entropy. So you can see on the left hand side, on the reactant side, this is your 2 mole and this is your 1 mole. Moles decreases, randomness decreases, entropy decreases, and hence delta S will be negative. Delta S will be negative. Now going for delta H. Delta H, for if it is positive, that represents endothermic, and if it is negative, that represents exothermic. Exothermic. Now you can see this is your atom and this is your molecule which have complete octet. So it will be more stable, and hence it is more stable. That means lesser energy, more stable, because you know that energy is inversely proportional to stability. If it is more stable, lesser energy, and since enthalpy decreases, energy decreases, delta H will also be negative. So the answer is C. Very good, Farhad. Very good, Saf. And no other answer from anyone. And in 2019, again, there were a question about this entropy, and look into it. This will be all for you. It's quite easy. Any answer? Wait a minute. Let me just check it. In which case, change in entropy is negative. Evaporation of water, liquid into gas, entropy will be positive. Expansion of a gas, volume increases, entropy will be positive. Sublimation of solid into liquid, solid to gas, it is gas again, entropy will be positive. Now here H2 to 2H, 2 mole, 1 mole. Entropy decreases, and hence the answer is D. Very good, Saif. And if think about it, the answer will be D. Okay, all of you, all the best. This is it for today. And if you have got any doubt, you can ask me at today or tomorrow, whenever, before your exams. Is that clear, Saf? Hanifa, Alan?
Yes, sir.
Yes, sir.
Okay, all the best. Be confident and then do your best as much. Okay. Okay. Thank you.
Yes, sir.
Thank you, sir.
Thank you, everyone.